This is Chapter 3. We'll be talking about averages and variation. We're going to begin with Section 3.1, Measures of Central Tendency. These are numerical values that will tend to locate, in some sense, the middle of a data set. There are various ways that you can do that. We're going to look at the three major ways to find these measures. The first is the mode. Second is median, and finally the mode simply means it's the value that occurs most frequently. Now, not every data set has a mode. If no value is repeated, then there is no mode. When two values occur with the same greatest frequency, each one is a mode. That means the data set is bimodal, so you will list both of those values. So let's look at a few examples. If we want to find the mode for this set of data, look closely and see if you can identify which value occurs most frequently. Does everyone see it? The mode is 4. We have 1, 2, 3, 4, 5 different times that the number 4 appears in this set of numbers, and that by far is the most. Check this example. Do we have a mode that occurs here? What number or numbers occur most frequently? If you've identified two distinct numbers, both 19 and 25, as the mode, you have this right. And that would mean this set is bimodal. Okay, the final example. Look at this set of numbers. See if you can identify the mode. Which number occurs most frequently? There isn't one. They all occur just once. That means there is no mode. Let's move on to the median. That will be the middle value when the original data values are arranged in order of increasing values. So if we're going to find the median, we first will need to order the data from smallest to largest. Secondly, if there is an odd number of data values, our median will occur in the very middle of the list. You could cross off from each end equally and see if the number that's left behind, if there's a single value in the middle. If so, that will be your median. However, if there is an even number of data values and you begin to cross off and you're left with two numbers in the middle, the median will be the sum of those two middle values divided by 2. You have to take the average of the two values. Okay, let's look at some examples to find the median. In our first set, we have this list of numbers. Notice this is the same set we used a moment ago and identified the mode. Are they in order? No, they're not. So what would you need to do first? Put the values in order. And that's what it will look like if you order it from least to greatest. Notice once you do that, it also makes it a little easier to identify the mode as well. It's very apparent we had more 4s than anything else. So putting them in order is not a bad idea. Now, to get the median, if we were to cross off from either end, you might practice this and see what happens. You will find the value you're left with is 4. Let's look at the next example. Again, this was the one that we identified as bimodal when we looked for the mode. Are these values listed in order? No, so let's do that first. And this is what it looks like in order from least to greatest. Now, if we begin to cross off values, you should notice we're left with two values in the center, 19 and 25. So in order to find the median, I'll have to add those together, divide by 2, and I will end up with 22 as my median. Now, is 22 even a value that occurs in this list? No, it is not. Your median does not have to actually be in your list of numbers or in your list of data, but it can be a different number when this happens, and you have to take the two middle numbers. Remember, median uses position rather than the specific value of each data entry. When given a small set of data, it is easy to scan the data to find the middle value. If you're given a large group of data, though, it would probably be more convenient to use a formula to find the position of the middle value. Now, do you believe that the median could be affected by extreme values? In other words, if we had most of the numbers clustered together, they're very similar, and there was either one very large number on the end or one very small number on the other end, is that going to affect our median? The answer really is no. That's the nice thing about the median. It's the middle number, so it really doesn't matter what those numbers on the ends look like. They're going to balance out as we take a number off of each end and work our way. Now, the mean is an average that uses the exact value of each entry. You should remember that in order to find the mean, all you have to do is add the data values together for every entry in your set of data and divide it by the number of data values. So if we were to practice finding the mean, we have 1, 2, 3, 4, 5, 6, 7, 8 different values here. Let's add these numbers together and divide by 8. So if you put those numbers in your calculator and sum them, you should end up with 169. If you take 169 divided by 8, you get a lovely little decimal number, 21.125. Again, your mean will often be something completely different than the set of data that you had. That will not look like a number that was in the set of data. It's not uncommon to end up with decimals when you calculate the mean. Perfectly okay. You may be told how to round the mean in case it ends up being a decimal number that doesn't end or doesn't repeat. Now, if I were to ask the question, is the mean affected by extreme values? Think about that for a moment. If you had to calculate your test average, and maybe you had 2 tests that your scores were 92, the second one was a 95, but on the third test you made a 21. Is that going to affect your average, your overall mean, significantly? Absolutely. If you compare it to what you would obtain for the median will be much higher than what your mean would be in that case. So it can be affected by extreme values. It will often depend on how many different numbers you have in your set of data. Now, let's talk a bit about the notation we use when we're going to be working with the mean. It is probably the one we will use most often. So x can represent any value in the data set. And we're going to now use the Greek symbol sigma. And so our notation is the summation of x is how we read it. But you see that Greek letter sigma in front of the x. And so the sum of all data values will be what we get if we add up all those x's, and the shortcut way of writing that is to use this summation symbol. So these are the formulas we will need for calculating the mean. Remember, we talked beginning in chapter 1 about different types of data. For example, we may only want to take a sample group, and when that happens, then we can get the mean of the sample, and we designate that it came from a sample by putting a bar on top of the x. So when you see this, that is x bar. And that would mean we would sum up all of the values in that sample and divide by the number of data values in the sample. So when I see X bar, I know it's the mean from a sample. But we can also collect information about the mean of a population. So if the data we're using represents an entire population, we use this Greek letter mu. Looks like a lowercase cursive u. And that would be the same process. We're going to sum up all the values in the set. The difference is now the set is the entire population, and we divide it by the number of values in the population. And to designate the difference between the number of values in the sample and the number of values in the population, notice that the sample uses a lowercase n, whereas the population will have a capital. So, if we were to use these formulas, we can add these up and divide by the number of items in our list. It's really the same process. We're just going to now designate this with the formula first. So we would start that way. Again, you're going to want to put these values in your calculator. And remember, if I'm finding the mean, do I need to put them in order from least to greatest? No, it's not necessary. I just want to add all those values together, and I will divide by the total number in the list. In this case, it's 13. 53 divided by 13 will give me a value of 4.08. And again, we talked about, can the mean be affected by extreme values? Yes, it can, especially, imagine in this list if we added an extra number and it was 1,275. That's going to change our mean significantly. So yes, extreme values can affect our mean. And here is a practice problem for you to just make sure you know what you're doing. You would need to find the mean, the median, and the mode of this data set. You're going to compare the three averages, and you're going to see if one might represent the data more accurately than the others. And we will go over this part of your notes together in class tomorrow when I see you. So, last slide asks us which average is not used much with numerical data. The answer is going to be the mode. The mode is more helpful when you're using data that consists of names, labels, or categories. We don't typically use the mode very much with numerical data. More often you're going to be asked for the median or for the mean. And that is our lesson for today.